A2 Crackers. Please subscribe my channel and watch it. Here the question number 1. Which of the correct pre-order traversal of the following binary tree? Here root is 14. Next 2, 11, 1, 3, 10, 30, 7, 14s are leaf nodes. Next options are given. Option A 14, 2, 1, 3, 11, 10, 7, 30, 40. Option B is 14, 2, 3, 1, 11, 10, 30, 7, 40. Option C 1, 2, 3, 7, 10, 11, 14, 30, 40. Option D 40, 30, 48, 11, 10, 7, 3, 2, 1. Here these four options are wrong options, because why we can see in the next explanation in pre-order traversal how we are finding. When we are finding the pre-order traversal, root to left, right, this is the order of the pre-order traversal. When we are finding the pre-order traversal, we are writing the each element so in the tree in left order arrow. In each element we are fixing left arrow. When we are finding the pre-order traversal, we are touching each left arrow in the order in likewise arrow in the direction likewise. We are finding the pre-order 14. We are touching the arrow in 14, 2, 1, 3. Next we are touching 11, then 10, 7. Then we are touching the arrow 14, then 30. This is our answer. In our option there is a small mistake in the option A. 40, 30, we are interchanging the elements in 30, 40 in the order. So the option A is wrong. Our answer is, the correct answer is 40, 30. Then the correct answer is 14, 2, 1, 3, 11, 10, 7, 40, 30. This is our answer. Next we can discuss about the binary tree, traversing in the binary tree. Tree traversal. Tree traversal is the process of visiting each node in the tree exactly once. Visiting each node in the graph should be done in the systematic manner. If search results in a visit to all the vertices, it is called traversal. There are basically three traversal techniques for binary tree, that are preorder traversal, inorder traversal, postorder traversal. When we are finding the preorder traversal, last we find out the answer of the preorder traversal. Root left to right, that means node left to right. To traverse the binary tree in preorder, following operations are carried out. First visit the root, next traverse the left subtree of the root, next traverse the right subtree of the root. Next explanation of inorder traversal. When we are finding the inorder traversal, how we are finding. And in preorder traversal, each element we can put it the arrow in the down arrow. Each element we can write the arrow in down. So we are touching the arrow here onwards, that is left side. Okay, left 1, 2. Then we are touching 3. Then we are touching 14. Then we are touching 7. Then we are touching 10. Then we are touching 40. Then we are touching 11. Then we are touching 30. Likewise, the visiting the each node and each elements. Next, inorder traversal means left node right. The traverse the binary tree in inorder traversal. Following operations are carried out. Traverse the leftmost subtree and visit the root node. Next, traverse the rightmost subtree. The last we are discussing about the postorder traversal, left to right node. To traverse the binary tree in the postorder traversal, following operations are carried out. First one is traverse the left subtree of the root, then traverse the right subtree of the root, then visit the root. Here this is the postorder traversal arrow. we are writing the arrow, then we are writing the arrow in the right hand side. Then we are touching how we are finding the postorder side. Then we are touching the arrow in the right hand side, 1 3, then the arrow here 3, then we are touching the arrow 2, then there is no arrow in the middle, then we are touching the 7, then we are touching the arrow 40, then we are touching 10, then 30, then 11, then 40. Likewise the order are visiting the post order traversal. Next, question number 2. Suppose we are debugging a quicksort implementation that is supposed to sort an array in ascending order. After the first partition step has been completed, the content of the array are in the following order: 3, 9, 1, 18, 19, 24, 22, 20. Which of the following statement is correct about the partition steps? Option A. The pivot could have been 18 but could not have been 19. The pivot could have been 19 but could not have been 18. C. Pivot could have been either 18 or 19. D. Neither 18 nor 19 could have been the pivot. Here our answer is C. 18 and explanation. 18 and 19 both are in the correct position or as in the sorted array. Also, all the elements of the left of 18 and 19 are smaller than 18 and 19 respectively, and on the right are greater than 18 and 19 respectively. Here in quicksort, in place partitioning is used. Best case complexity of quicksort is order of n log n. Average case complexity is order of n log n. Worst case complexity of quicksort is order of n square. Worst case space complexity of quicksort is order of n. Here this is our quicksort algorithm. Divide, recursion, conquer. Divide the input data into 2 more parts. Recursion, solve the subproblem recursively. Conquer, combine the solution of the subproblem into given domain solution. We are writing quicksort algorithm A, P, R. Next curly brace. If P less than R, Q equal to partition A, P, R. Quicksort we are left and right part dividing into partition A, Q minus 1 and A, Q plus R. We are finding the time complexity of divide and conquer algorithm in recurrences T of n equal to A of Tn by B plus F of n greater than 1 and T of 1 equal to 1. This is the time complexity n equal to 1. Here the quicksort pivot algorithm. Partition of A, P, R, x equal to A of R and I equal to P minus 1 for j equal to P to R minus 1. Then if A of j less than or equal to x, I equal to z plus 1 and exchange A of I with A of j and exchange A of I plus 1 with A of R and return I plus 1. This is the pivot algorithm. Thank you for watching and please subscribe my channel.